A newly discovered black hole has been dubbed the hungriest black hole ever detected. Scientists from the International Gemini Observatory and NSF Noir Lab say the void, called LID 568, devours matter at a rate 40 times faster than the theoretical limit. This black hole is having a feast, said study co-author Dr. Julia Scharwachter. Using the James Webb Space Telescope, JWST, the researchers were able to observe LID 568 as it was just 1.5 billion years after the Big Bang. Even at this early moment in the universe's formation, scientists saw that the black hole was producing far more X-ray radiation than should be possible for its size. Its massive appetite could help to explain how some tiny black holes become supermassive so quickly. Dr. Scharwachter says, "This extreme case shows that a fast feeding mechanism above the Eddington limit is one of the possible explanations for why we see these very heavy black holes so early in the universe." The researchers are now planning follow-up observations with the JWST to further investigate the possible mechanisms at play. Scientists believe that every black hole has a maximum rate at which it should be able to absorb new material. This is called its Eddington limit, named after English astrophysicist Sir Arthur Eddington. This is the point at which the black hole's inward gravitational force is balanced by the outward force generated by the heat of infalling matter. If a black hole exceeds this limit, astrophysicists theorized it would become so bright that the surrounding gases would be blasted away. However, when scientists looked at a sample of galactic cores extremely far from Earth, they found that one was glowing with unusual intensity. While invisible in the visible and near-infrared parts of the spectrum, the ring of material around LID 568 was giving out 4,000% more energy than its Eddington limit should allow. The researchers believe this might be possible thanks to a number of powerful gas outflows around the center of the black hole. Since LID 568 is so faint, the researchers opted to use an instrument called the integral field spectrograph, rather than the JWST's usual methods. While this technique is not as focused, it allows the researchers to measure the spectrum for each pixel in the instrument's field of view rather than being limited to a narrow slice. Thanks to this decision, the researchers were able to get a full view of the region around the black hole, revealing unusual outflows of gas leaving the black hole at speeds of 600,500 kilometers per second, 310,372 miles per second. The researchers think these outflows allow a black hole to exceed its Eddington limit by acting as a release valve for the excess energy created during a massive feast. This also suggests that the black hole may have gained a substantial part of its mass in a single episode of extremely rapid consumption. Lead author Dr. Haiwan Su. This serendipitous result added a new dimension to our understanding of the system and opened up exciting avenues for investigation. 1.5 billion years after the Big Bang, the earliest galaxies were already beginning to form, and with them came the galactic nuclei that are at the heart of all galaxies today. Recent observations have shown that many of these faint, dusty nuclei contain supermassive black holes shortly after forming. Just like the black hole at the center of our galaxy, Sagittarius A*, these are incredibly dense points of matter with a mass at least 100,000 times greater than that of our Sun. Current theories suggest that supermassive black holes form from smaller black hole seeds, formed very early in the universe's history. These could either be heavy seeds, formed by the collapse of vast gas clouds, or light seeds, created by the death of the universe's very first stars. The puzzle for astronomers has been to explain how these seeds grew so quickly into supermassive black holes without exceeding their Eddington limit. This discovery suggests that some black holes may be able to temporarily exceed this limit during rapid feasts of nearby matter. Dr. Su says, "The discovery of a super Eddington accreting black hole suggests that a significant portion of mass growth can occur during a single episode of rapid feeding, regardless of whether the black hole originated from a light or heavy seed." Thanks for watching. Don't forget to subscribe.